Okay, let's start. I don't even know where I am last time. Okay, so I think we have some kind of infinite loop here. When we add a node, right? The size empty, okay. Maybe. Okay, so let's be a little bit defensive here. If not node, then we also return, right? And we have to solve the situation when the node that we're removing is its node is your head. Right. If the node is the head, then we need to fix the head. Okay, before we do this, before we fix all this stuff, if node is cell.head, then head gonna be head.next. Right. If node is actually cell.tail, right? Okay, so what happened in the case where both head and tail point to the same thing, right? Else is node equal to cell.tail, cell dot tail equal the one we're removing cell dot previous. Right. If cell dot head equal if cell dot head equals cell dot, okay. If cell dot head equals cell dot new head will be equal to cell dot head dot next. Cell dot head equal new head. If cell dot tail equals cell dot head, so that tail equals cell dot next. For sure, right? And then we check this, good. So this move node to front is nothing but insert that node, right? Insert that is nothing but add node, right? So let's do that. Add node shall key value, right? Actually, right. So if size for 0, then you basically can copy this. So remove this here. Okay. So basically, we have that function. So this one right here, it gives in. So when we remove node, right, we do shell.size -1, right? So basically we remove node, add node, right? Okay, so we can remove this. And this code situation is if key is found, then change the value, remove key node, node dot value, this is add node. It shell dot add node, right? So this is basically node. Shell dot node. Key value. So this function is the same. Okay. So if key is in, we do this. If capacity is still can add, right? Out of capacity. Okay. So when we out of capacity, we want to when we remove node, remove node, we also delete the key. Right, so basically if node.key is in shell.keyTracker, and we delete that. Right, this is nothing but delete the tail, right? So this cell dot remove node. This is cell dot key tracker. Cell dot cell, right? And when we remove, we gotta cell dot node key value, right? Let's run this. Is not defined. What? Oh, this is node. He's not defined. Oh. Yeah. Oh, forgot to. We're doing this right now. Because that. Let's see. Okay. Let's see. Let's take out all the printing. Take out all the printing. See if this case is working through. Okay. Wrong answer. Oh. Oh. Why is it wrong answer though? What is wrong? Show me the diff, bruh. Okay, let's read the description again. Every time we call get, right, this means this should move to the front, right? So when we out of capacity, we evict the one at the bottom tail, right? Okay. Not found. Let's remove this. Remove the node. Yeah. And when we add node, we add the key back, right? Yeah. Okay. So something we did is wrong and we don't know, which is big cascade. Yeah, they don't tell us what's the difference. But wrong answer. Something here in the logic we did is giving us wrong. The key not in tracker, then get the key. So and we take the key out, we add them. So what could be wrong? Oh wait, hold on. If the tail here, we have to do the check here. If cell dot head here equal to cell dot tail, right? For some reason. So then cell dot head. I don't think so, but let's just do that. So the one we remove is actually equal to the tail, and if the tail is actually use the head. Then the only way where you can remove the tail, and it's also the head, which is we check the tail. So the one we remove is the head. Then head dot next, right? See if it still will work. But you're wrong. Something we did is wrong. So if it exists, we get it out, change the value. Yeah, we remove. Change the value. We add them back, yeah. So remove and add the take care of -1 and +1. Right? Yeah. So otherwise, the key doesn't exist. And if it is less than capacity, then we add the new node to the front. So point link the bottom, and then point the head to the new one here. Track the node to the node key, right? I'm seeing things wrong here. Out here mean we out of capacity. That mean we remove the node. Remove the node, which is the node we're removing is head, then we gotta fix the head to the next one. Right? If head equal to tail, then the tail had to point to the next one. Right? And if the one we remove is the tail, then gotta fix the tail first. In the case the tail is equal to the previous. I don't think it changed anything. Okay. What did we do wrong here?
All you need to do is chant the phrase, I sacrifice.
I don't want to put all of this in paper and try to visualize them. It's insane. Or maybe what we did wrong, probably here is, when the key exists, do we have to move them to front? That's the question. Randomize stuff. No, we have to. Right? So, what about in Get Here?
You're the only one
And
who made me forget my dream.
something we did is wrong.
I sacrifice.
The key in cast, I don't see anything wrong with it. If the one that we're copying is a tail, then the tail point back to if there's the previous, then tail previous, right? And so when we remove the tail, something is wrong with the big case here. When we add the node, what's wrong here? Right? So, what the hell is wrong with this case? You can't know what's wrong here, so that means that some logic here is messed up. Don't see why yet. Right? Something is up here. Maybe. So, can we do some test case that I just wrote on the paper here? run this. Method to be a string. What? What? We just put some test case here. Do some more test case that's smaller. Okay. 2 on 1 2 2 1 3 3 2. Okay. K4 is the one that is wrong.
Slammed door, last time, run home, rain
What?
hard, lose job, turn key, mood swings, last time.
Okay, fine is fine. K4. Do another one.
Door, jam, write, note, take, meds, black, sun, drift away, old world, lights out, time's up.
You can redo so much. They won't let you. Yeah? So what did we do wrong? Wrong answer.
Lights out. Lights. Lights out. Lights. Lights out.
Maybe this. Try them out. What did we do wrong? No? That's correct? I couldn't think of any other test case. maybe there's somewhere here that unlinked wrong. Maybe we should only do this. This is extra thing, right? If keynote here is equal to the head already, it's not equal to the head. Right? We don't want to do extra insert, right? But that's just optimization. Hmm. Hmm. So remove when it's the tail and make it become the previous. Good. And then add the back to the front. Right? I don't see anything wrong here. Just want to confirm that all the case that we thought of is working first. Run this. There's something wrong here. What did we do wrong? Right? And since we do the same thing in here, or forget, let's do that for the node. Okay? I don't think it's doing a difference, but sure. Keynote equals cell dot head, not equal to cell dot head. And do this. Right? Otherwise, we basically saying that link them, right? So remove node. When we remove node, we unlink them, and if it is a tail, then we not make sure the tail is correct, and then wait a minute, guys. Think. Just want to make sure, right? When we remove them, okay, just want to make sure here. Okay. So maybe some dangling previous that we did. Okay. And okay. So just want to make sure we did it correctly. When we remove, we do this, right? And we also enforce this here as well. Let's see. Yes, that is the case. Oh my god. Commit. Alright. So this is my runtime. That's fine. We want to want to tell them some of the big case here, right? So the screenshot, we gotta write about this later. Okay. So do we call any debug? Make sure that, yeah, so when we write about the subset, talk about some projected population. When we unlink, we should always do right. Okay. So we did that, right? Okay. So do we do next one? Yeah. Yeah. Merge interval. Merge interval. All right. Is this one? So how many questions are there? Probably 3. Topic. Hey. Oh, okay. So you have to, given an array, gotta merge all the interval, right? Since interval 1, 3, and 2, 6 overlap, do we just sort and then do a so as soon as so like when we sort, like we sort 1, 4, right, 4, 7, and then we keep going, and if we can merge them, we pop and then we insert back, right? Or we can put it into the new array or something, right? Right? So we sort by the first element, and we keep looking at 2 elements, right? If they can be merged, we merge them and pop the top and then insert the one, right? Right? So let's do that. Right? So let's do that. Okay, so I think Python sort list of list. Okay. So can we tell it to to sort key x x. Okay. So interval sort we have to pass the key, right? Key equal lambda and x, and we want to sort by the first element, right? Okay. So do we want to reuse the interval? I guess we could. Right. So I equals 0, yi is less than length of interval minus 1, right? Because we compare two elements, right? So let's call it L R. Interval I interval I plus 1. Okay. So now is it inclusive? As in, so now because we sorted them, right? So the left side is always gonna be either the same or equal, right? So for example 1 3 and 2 6 here, right? So first, if both the left side is the same, right? So both, like, okay, 1 4, like for example, let's put some case here. We have 1 2 and 1 3, right? So if do they have duplicate? Let's assume that is the case, right? So right, and okay, so in here, if the one less than okay, hold on, when it's stored, does it also give me, okay, let's just sort here. I think that should work, right? So if the case like that, or couple cases that we have to think about like that, right? So then we pop the front, pop the both two, and insert the, okay, so we can do this. Okay, so okay, so let's just pop interval dot pop interval dot the Python array pop. Does it pop the first element, right? Let's just pop 0. 0. A. Let's just call the interval A, B then. And after we done with the merge, right, if we can merge, then so if they are equal, if this is equal, then for sure it's overlapping, right? Just gonna be the new merge gonna be, let's call this interval equal to, gonna be okay, let's just call this left is fine, left right is fine. It's gonna be whatever this is, right? The right gonna be the max one, right? Max up right plus interval, right? So because we can merge I plus equal 1, 0, 1, 2, we pop 2 out and we get the new one. So plus equal 1 stay the same, right? So if it is not equal, then we check if this is in this range, right? So left right greater than or equal to no, left right 0, and can we do this in Python? I think we could. Right, so this is like, if they're not the same, then this could be 1, 3, right? And even 1, 2, and wait, 1, 2, 2, 5, like this. So 3 is in this range, right? 3, so like is 2 in this range? Look like, yeah. So 1, 2, okay, so it has to be greater than this, right? And less than the other one. So equal. So what happened in this one is 1, 3, 2, 6, right? Or what about 1, 6, 1, 3? So the left greater than these two values, greater than this. So like 4 in 3 and 4, right? This should be 1, 4, right? Should be 1, 6, right? So then interval gonna become L0 to the L1 plus interval, right? So otherwise, no overlap, right? Then we simply check the next one. So this is I plus 1, right? Okay, so if there's overlap, we already pop them, we insert them. Then I stay the same, right? Because we, after the insert, we might have a candidate after that, right? If there's no overlap, then plus 1. Okay. Like that. Maybe we have infinite loop, who knows? But it's integer. Oh, what did this sort function do? Right, 1 3 2 6 8 2, yeah. We pop. What is left and right? Oh wait, hold on. Yeah, this is the issue. And we got the list of this. What? So let's print the overlap before and after. Okay, 1 6, good. Okay, so if there's no overlap, okay, we forgot to insert them back. Right. So there's no overlap. We want to check this because there might be this one, then this one. The hell? Oh, this is already okay. We have extra bracket. Okay. Okay, one is good. Wait, so this is fine. Okay. Let's submit and see. case is wrong. We output 1 4 2 3. Oh, so 4 is not this. Okay, we have to also check the other case. So we want 1 4. Right, so okay, I see. So, or the right greater than the left 0, but less than the left 1. So in this case, basically the left gonna be a max, a min of okay. So let's pick the thing here, right? It's gonna be the min of min of these 4, right? Right. Should we do that, or should we just do this? We make this another case. Right, Elif. So if this one is in, then it's gonna be gonna be this, right? Okay. Submit. What are the cases that we have? Okay. 4 5. Oh boy, we do really want to okay. Does this mean that we got 1 3 correct? 4 6 and 5 7 we did not, right? So this is actually We get some water. Or if we have these 4 value, right? Oh, and we can get the min and the max out of them. So the new range gonna be min and max, or whatever. Let's just do this. So if the right 0 is greater than this but less than this, right? So for sure it's gotta be L0 here, right? And gotta be L0. The right here is actually gonna be max of R0 and no L0 L1 max of L1 and R1. So it will be 6 or 7 and 4 7 like that. Okay, let's see. But okay, so let's print them. Okay, so this is R0. No, R0, yeah. Greater than or equal to L0, right? And less than or equal to L1. Give me one for good. Oh, we missed up one case. Okay. Print interval here. What? Oh, that's not equal, guys. Oh wait, no. Less than is correct. Right. So yeah. So in this case, look at these two, okay? Why didn't we look at Okay, so no overlap, right? When it's no overlap, we plus or equal to 1. And it becomes this. So let's also print out the I here. We off by 1 or something. And now after that we got a new interval and the current I is equal to okay, so 0, good, so these two. When I equal 1, wait a minute. Okay. So when we did wrong because so when I equal 0 we do this and we found that there's no, is that 1 6, right? No 1 3 4 6. So we gotta basically pop these and these, right? So I and I plus 1, right? So we compare them. Wait a minute. So the wrong thing here is even though I equal to 1, we pop these two. We wanna pop these two here, right? So we wanna compare and then we do the insert correctly, right? Okay, hold on. So don't pop this. Let's just do I and then I plus 1 here, right? So this means that we be able to add the new interval. That means we need to interval beginning to I, right, plus this interval and then I plus 2 to the end, right? We want to skip I and I plus 1 because we got the we got the new interval here. Okay, so now also do the same thing here. Same thing here. Okay. So if there's no overlap, we actually we don't do anything, right? If there's no overlap, like this case 1 3 and 4 6, we just increment by 1. Yeah, try that. Okay, so let's remove all the printing and submit and see. Do we print anything? No. Okay. Submit. Alright. You only beat 5% though. That's fine. Fine by me. Alright. How we doing? Next question. How's Robert? Here's the problem here. Okay. Automatically contact the police if two adjacent house was broken into. So that means if we pick the 1, we cannot pick the 2. We have to pick the 3, 4, 5, whatever. Right? This look like a dynamic programming syntax, I think. So let me write them down in paper here. Go through some of the example. Right. Where's my pen? How's Robert? Okay. Okay, what case here? 1, 2, 3, 1. So 1, 2, 3, 1, 0, 1, 2, 3. Right. So now, if I start at 0, that means I start at 1. Do we do the sum? Okay, sum up. Okay. So 0. From 0, we can do 2 or 3. 0 into 2 or 3. Yeah. So if we do if we do 2, that means it's gonna be 1 plus 3 gonna be 4, right? So at 2 we cannot do anything, so that gives us nothing, right? So now we backtrack the tree. So from 1 we can go from 0 we can go to 2, that is 4. 0 we can also go to 3, so that is 1 plus 1 is 2, right? So 2, right? So with that, okay. So now we look at 1. We start at 1. We can go to 2 or 3, right? Oh wait, so we start at 1. We can only go to 3. So that's 1, 2. 2 plus 1 is 3, right? Right, so this give you a 3 back to here. So 1 can only go to 3, right? So right. Okay. So and if we start at 2, right? Okay. So we start at 1. We can, the max is 3. Right, so 0 the max is 4, 1 the max is 3. Right, so if we start at 2, that means we start at 3 and we can go nowhere. So 2 is 3. Right, so the end result is, like I said, is 4 here. So that means if at any point if we jump into the house, and if that house right, it's like a graph and then you bubble up, right? So for example, everyone started at 1 0 1 2 3 will be 1 2 3 1, right? So we can go from the back. So we start at 3, right? No, we should be able to start from the front. Right? So this guy is overlapping, right? So if we start from here, we can jump to this. And if we start from this, we can jump to the next +2, right? Whatever. So if any other guys here, we want to prevent them from like going down the tree, right? So that means if the value that they started to jump to this, so let's say it was 2 here, right? You can only jump to 1 here, right? And if the 1 here is a max value, is some value, right? Then we cancel the 2 3, right? That's what I'm thinking. But let me sketch them out with this case right here, because we have 2 7 9 3 1, so 0 1 2 3 4, right? So if you start at 0, you start at 2, you can go to 1, or you can go to 2, or you can go to 3, or you can go to 4, right? So now if 2 you go to 1, that means 2 plus 7 gonna be 9, right? So now you go to from 1, you wait, hold on. If you go 0, you can go, oh sorry, you can go only to from 0, you can go to 2, sorry, or 3 or 4, yeah. So if you go to 2, then that is 9, so 9 plus 2, right, is 11. So from 2 you can go to 4, right, which is 11 plus 1 is 12, right? So okay, So now we backtrack the tree. 0 to 3. 0 to 3. 2 plus 3 is 5. Right? Okay. 2 plus 3 is 5. And from 3 you can go nowhere. Okay. So 0 can go to 4. Well, 2 plus 1 is 3. Right? Okay. So now we start at 1. If we start at 1. Okay. So 0, 1, 2, 3, 4. So 0 go to 2. That is 0 to 2 is 11 here. So 4 is 12 here. And 3 is 5 here. Okay. Actually 0 shouldn't even go further than 4 because 4 already give 12, right? So cancel that. So now we start at 1. We're starting at 7, right? And 1 can go to 3. So if you go to 3, right? That's gonna be 7 plus 3 is 10, right? So we see the O value of 3 is 5, right? So we override that. So it's gonna be 10. Okay. So okay, so 1 can go to 3 or 1 can go to 4, right? And go to 4. It's gonna be, but 1 cannot go to 4 because 4 already has 12 value in it, right? Right, so right, so 7 plus 1 is 8, right? Okay, so 8 is not greater than that, right? Okay, so now we start at 2. Right, so we start at 2, which is 9, right? So at 2 you can go 4, right? But 4 is already have 12, so we do nothing, right? Similar, we got 3. We start at 3. 3 can go nowhere, right? So, which means maybe we can reuse the nums here, right? That maybe, possibly. But let's just allocate an array for that, right? So we start at 4 for the sake of completeness. So 1 we can go nowhere, right? Which is what I have here. So let's do that. Okay. Okay, so we do a function called route helper, and basically the answer is none. Oh, we can just do this. Let's call this cache equals 0. Right. So return max cache, right? Right. So basically we gotta run rob helper starting at 0. Okay. For I in range of main num, right? For rob helper on I, right? So starting at index I got the starting value gonna be 0, right? So so if we do this, we can only do for j in range of I plus 2, right, to the length of this, right, for Rob helper on j, right? So the money, so like total money, right? So it's gonna be total money plus nums I, right? Right, so right, let's run through some of the numbers here, right? So we do 1 2 3 1, right? So 0 gotta go to the number here, this one. So first we got a 0, can go to 2, go to 4, right? Means 0 here is 2, 2 here is 11, right? So 2 7 9 3 1, right? So 0 2 here is 11, 12, right? And then we backtrack. 0 can go to 3, 2, 0 1 2, so that is 5, right? Uh 0 can go to 4, which is, we really should make a new array then. 0 0 0 0 0, right? So 0 1 2, so that you started through here, and this is 11, right? And then 11 plus 1 is 12, right? So now 0 1 2 3 is 2 plus 3 is 5, right? 0 plus 3 Wait, hold on. Let me do one thing. Maybe it will work out. Hold on. So we got, can we just go from the bottom, right? So we got 0 0 0 0, right? We go from the back, right? So if somehow we landed in here, right? This will be 1. We just start from here, right? So from here we can only go these or these or these, right? Which we keep the map, right? So 10, right? 8. But yeah, let's just go with the top-down approach, right? So that is 0. So 1, 0, 1. So 1 can go to 0, 1 here, can go to 3 or 4, right? 3 or so basically, right? Okay, so let's do that. So we starting at this 0 here with the amount of money is nums I, right? So we go from this to that, right? So if we couldn't, then so we do if cash j equal 0 or okay, so first for 0, then cash j gonna be equal to total money plus num num j, right? So when we get 0, we start at 2, we jump to 0, right? 2 is 11, right? We filled up this array in 12 here as well, right? So if or so total money plus num j greater than whatever I have in the value, right? Then I do this, otherwise I just do that. Let me try that out. What? What? Why is J? So we started this. If we started this index, we can only pick the value that is from I plus 2 to the end, right? So let me print the value here. Okay. 0 cash J. What? Oh, this way. There we go. So I think this should work. Uh-oh. Time limit exceeded. Oh, wrong answer. What? Oh, we forgot to start the cache with if cache I if cache I equals 0, then cache I equal to num start, right?
Incoming transmission.
What?
Well. Looks like you went offline. Hey, we're all here waiting for you. So hurry up and let's get it.
I'm on the
Okay.
way.
Uh-oh, something wrong.
Redirecting power. System ready.
Time limit exceeded, bruh. If nums is all 0. Wow. Here's the test case here. How rubber. Oh, this is the case when it is. Okay, so let's do negative one then. What a bummer. Right? Oh. Oh. This one. Yeah, that should work. Yeah. Wow. Nice. Back to quest. Hold on, let's do it this next time because I'm hungry now. This is a submission. Can we go back to quest? This is what? Probably we can I'm tempting to I have to probably go grocery right now. When I'm back from grocery, I probably go cooking and then game. Then we're back at this at the night time maybe. But that was it. Thank you. Bye now.